Hello, everyone. If you joined the live stream of the introduction to FHIR at the DevDays, you may have noticed that we've had a little bit of problems with the audio quality. That's why I decided to re-record this whole session. And since there's no time limit now while I do the re-recording, I also decided to make it the extended version of the FHIR introduction. So welcome, everyone. First of all, let me introduce myself. My name is Simone Heckmann. I'm CEO of FHIR GmbH. We are a company based in Germany, and we are specialized on providing consultancy and training for HL7 FHIR. And I've been doing trainings both in Germany and abroad since 2015. I'm also chair of the technical committee for FHIR at HL7 Germany and also a board member of HL7 Germany. Before we start talking about the FHIR standard, I would like to talk a little bit more about what HL7 actually is. Because there's sometimes there's quite a lot of confusion around what an HL7 standard is and what isn't. So HL7 basically is not a standard, it's a standards developing organization. And there are plenty of products that HL7 has created over the years. We will take a look at them later. But the organization itself consists of volunteers from all over the world, all over the healthcare domain, and they are organized in what we call working groups. And these working groups are specialized on certain topics around healthcare, either patient care or patient administration, for example. And they meet virtually through phone calls. There's a conference platform that people use to share documents. There are chats, email lists, and they are very open. So if you want to join any of these working groups and help developing these standards, you can quite easily do that by simply going to the hl7.org homepage and browse to resources, and there you will find the listservs, which are basically the email lists for each of these working groups, and you can subscribe, and then they will let you know when the next phone call will happen, how to dial in, or what is currently being discussed in this working group. The organization HL7 has been around for many decades. It started back in the 80s. That's when the first working group meeting was held, and the first time these working groups were established and were meeting and discussing standardization in healthcare. And soon they published the first specification of a interoperability standard for healthcare. And one of the earliest and one of the most successful products of HL7 is the standard called version 2. And version 2 today is probably the most prevalent standard in healthcare. Most of the communication within hospitals is based on HL7 version 2. It's not that there haven't been other products or newer products by HL7. It's just that this one specification has been so widely adopted and so widely used that it's often called just the HL7 standard. So if you hear anyone talking about the HL7 standard, what they usually refer to is HL7 version 2. But you have to keep in mind that HL7 is more than 30 years old. It's actually older than the World Wide Web. So you can quite imagine that it's not up to the latest standard of communication anymore. But it's still under development, it's still being widely used, and we will still see updates to this standard. If any one of you have never seen what an HL7 version 2 message looks like, that's basically it. We have these different message segments. We have a message header segment with metadata for this message. We have, for example, a PID segment with patient demographic data, PV1 segment for encounter information, for patient visit data. And the individual fields are basically separated by this pipe symbol that you can see right there. And that's basically how information is being moved around within hospitals. Since HL7 version 2 is a message-based and event-driven standard, the environment that this creates looks in many cases probably like this. We have a primary EHR system, and whenever an event occurs in this primary system, for example, a new patient is admitted or a patient is discharged, this event triggers the sending of a message to any of the other systems in the same network. And these systems then will store the information in their own database in order to make it accessible to whatever end user application these servers support. And the right side of this slide, of this communication, has never really been touched by any of the HL7 standards. The way the end user application is accessing the data in its own server backend has always been up to the vendors. That's been mostly proprietary stuff happening there. Some used direct database access, others created their own REST interfaces. But these were not interchangeable. They were not standardized. So every system basically has to come with its own back-end server that basically needs to plug into this message stream to be populated with the data that the end user might or might not need. But with new technology, there comes new challenges. And with the introduction of mobile devices, there has been an expectancy that the servers simply exist. The mobile device doesn't come with its own back-end server. It just expects there to be an infrastructure, maybe in the cloud, somewhere in the web, that has a query-driven interface, that has an open API that this device can connect to and exchange data. Most of the cases, it will be JSON formatted information, and using the HTTP protocol to move data around. These devices don't want to have anything to do with message-based communication with these pipe-separated things moving around through TCP/IP or file transfer protocols or anything. It's just not a good fit. It's basically impossible to integrate any mobile device into an HL7 version 2 based environment. So these three guys one day decided that the world was ready for a new standard. And they decided to tackle these issues, to find a standard that enables mobile devices or any kind of end user device, basically, to plug into a system with an open API and retrieve whatever data they need whenever they need it. You've already gotten to know Ewout. He gave the introduction yesterday, and you've probably already by now have heard talks by Graham Grieve. He's the guy in the middle. He's our product manager for HL7 FHIR. And you will see and hear a lot from Lloyd McKenzie, the guy on the right. He's probably, if you ever ask the question in the FHIR Chat, in the international FHIR Chat, he will probably be the one who gave you a very kind-hearted answer. So if you have any newbie questions in the chat, don't be afraid to ask. He will probably be the one who will give you a very kind response and indicate where to look for the responses that you are looking for. So these three guys are still very active in the community, and we're very happy to have them around and support the community basically all the time. Since one of them is based in Australia, one in the Netherlands, and one in Canada, you can basically have a guarantee that one of them is always awake and able to help out if there's a problem in the community. So the idea that these three guys had was to create an open API that allows any device to plug into an EHR and retrieve the data that they need. So, and to use a web-based approach to the solution that these kind of devices basically expect. And the solution they came up with was called FHIR. The acronym stands for Fast Healthcare Interoperability Resources, as you probably know by now. And healthcare and interoperability goes without any further explanation, but the F for fast kind of is the promise that this standard should provide easily implementable solutions. And the R for resources stands for these individual pieces of information that are being moved around through the FHIR API. FHIR goes back to the year 2011. That's when the first draft was published. And soon after, there was a first connectathon. Connectathon was basically a challenge to implementers to use this new drafted standard and try to create implementations, try to make something with it and give feedback to the specifiers and talk about their experiences, make suggestions on how to improve the specification, how to expand the specification, to make it a better fit for the problems that the implementers are trying to solve. And to allow implementers to just not just tinker around with the specification, but create actual software that's runnable and that can be used in production. There were regular releases of FHIR, stable releases that could be used to build implementations on. And these releases were called DSTUs, Draft Standard for Trial Use. You will probably hear a lot being talked about DSTU2 or STU3 and what version are you using. So I think it's important to know what this actually means. In the year 2017, we had a third release of FHIR, and they decided to drop the D because it was no longer a draft standard. It was an actual standard now. But they still left the trial use appendix there, meaning that the standard was not yet normative. So there was still the option to change the specification based on the feedback, based on the experiences that implementers reported. So in December 2018, we have the release that currently at this point in time is still the latest release. It's R4. And so now the trial use appendix is gone. That means that this is the first time that we have a release of FHIR that has normative content. It's not all of the specification that's normative. There are still parts there that still need more testing, need more experiences, but the basics of the standard are now stable. But that also means that there will be more releases in the future. There will be an R5 release sometime later this year, maybe early next year. So there will be future releases of FHIR where more and more parts of the specification become normative. The development of FHIR is based on a set of rules that we call the FHIR Manifesto. And these rules are, first and foremost, the focus on implementers. FHIR is supposed to be a standard that makes life easier for implementers. It's supposed to be easily implemented. So whenever something is being specified, the needs of the implementers are in the foreground. And one consequence of that is that we are trying to keep the standard as simple as possible. But that also means that we cannot standardize each and everything that anyone could possibly need. We need to make a cutoff to keep it as simple as possible. And this cutoff is the 80% rule. That means if something is expected to be used in 80% of the cases, that's when it's going to be a part of the specification. If it's not used in 80% of the cases, it will have to go to what we call extensions. So you basically then will not find this element as part of the specification, so you'll have to extend the specification for your specific needs. Another rule is to focus as much as possible on reusing established web-based technology. So the implementer will always find something in FHIR that they already know, like protocols or serialization formats, things like that. Nothing's being reinvented for FHIR. We are using as much established and well-known technology as possible. Another point is to make every information that is moved around in FHIR as human readable as possible. This not only means that there will be a human-readable representation of all the machine-readable data, this also means that we try to make the machine-readable parts as human-readable as possible to simplify debugging, make it easier for readers of the specification, for implementers to understand these resources. Then we have a focus on the community. FHIR is a community-based standard, and the community is very important in supporting developers and implementers that use the specification and drive the further specification of FHIR. Finally, we have the focus on scalability, which means that we are trying to provide simple solutions to simple problems, but we also need FHIR to scale up to the very complex issues in healthcare. That there's quite a lot out there in healthcare that looks simple at first look, but when you dig deeper, you will find that it's actually not that simple. And so whenever we have these complex problems to solve, we need a standard that scales well. When people ask me what FHIR is and what you can do with it, I tell them you can do anything with FHIR. There's not one use case that FHIR supports. I like to think of FHIR as one of these Lego kits. I hope everyone knows what I talk about when I mention Lego kits, and I hope they're not just a European phenomenon. So basically, they are these kits where you have different wheels and gears and sticks and bricks, and you can basically create anything you want. If you can imagine it, you can build it with these sets. And that's pretty much what FHIR is. It's the equivalent of a Lego kit for healthcare interoperability. And funny enough, if you go to the homepage of the FHIR specification, you will find that it kind of looks like one of those kits. It has these different compartments that arrange and group these different parts that you can use. You will find a foundation compartment where you have all the basic stuff that you need to know about FHIR. Then we have compartments for the security and privacy parts, for the terminology bits and the exchange bobs and the administration parts and the diagnostic wheels and the workflow gears and everything you need to assemble whatever you have in mind, whatever you are trying to accomplish with FHIR. There's another view of all of these parts. That's the resource overview. The resources, as mentioned, they are basically the different parts that we have in FHIR. And you can see that these resources neatly arranged in their different compartments right here, so they are easy to find if you're looking for anything in particular. They have either a number or a green box with an N in them behind the name of the resource. And this is an indication of the maturity level. The maturity level indicates how widely a resource has been tested. And it ranges from 0, meaning that this resource is basically just an initial draft, over 1 and 2, which means they have been tested in a connectathon, have been tested in the real world, have been tested by multiple companies in multiple countries, until the resource finally reaches level 5, which is equivalent to being normative. Normative means that once this resource has been published in its normative status, it can no longer have any non-compatible changes. So these resources are stable. People often ask me whether it's okay to use resources with a very low maturity level in their implementations. And I like to encourage people to use these resources, because maturity levels 0 basically means that you are expected to do something with these resources and give feedback to the responsible working group on whether you like this resource, whether it fits your requirements, or whether you have any proposals on how to change and how to improve these resources. So there's basically a chance there that if you use a resource with a low maturity level and you get involved and get in contact with the working group, that you can actually help to improve these resources to also better fit your requirements. So go ahead, get an overview of what resources you want to use. And if you find any resource in the mix with a very low maturity level, just step in contact with the working group, and just, even if it's just listening to what they are discussing, so that you're prepared when you know that they are planning to do changes, that's going to be very helpful, both for you and for the working group. If you want to take a closer look at what any of these resources look like on the inside, you can just follow the links here in the overview, and then you will be directed to a page that gives you this tree view. This tree view is one way to inspect a resource. There's also UML representation or XML schema. So that's up to your personal preference, how you want this to look at these resources. But I think the tree view is probably the most human readable of all of them. And now you see the different elements that make up, for example, the patient resource. We have a column that's top with the cardinality that will indicate whether any of these elements are mandatory or whether they are repeatable. We have the type column that indicates the data type of this element. In FHIR, we have both primitive types like Boolean, string, date, and so on. And they start with a minor case letter, so you can tell from the name of the data type whether it's complex or primitive. If it has an uppercase letter, it will be a complex type, meaning that this element has a certain number of subfields. And if you want to know what these subfields are, you can just follow the link in the type column, and it will direct you to the page where the data type is specified. In the last column, in the description and constraints, you have a short description of how this element is supposed to be used. If the short description is not conclusive to you, you can also follow the link in the first column that has the name of the element, and that will direct you to a more comprehensive description of the element. In some cases, you will find that there are links in the description column, and that happens if an element is connected with a value set, meaning that it's an encoded element that allows only a certain number of values. And this link will guide you to a page where you get an overview of what these possible values for this field are. This is an example of what an instance of a patient could look like in FHIR if you decided to represent it using XML. FHIR has both the option to represent your data in XML, but also in JSON. And usually it's up to the client to decide whether it wants to use the one or the other. Servers usually support both representations, and clients can decide which one they prefer. So this is an example for an XML encoded patient resource, and the elements you see in the blue box, they are part of what we call the narrative. The narrative is a human-readable representation of the contents of this resource. In this case, this human-readable content has been abbreviated for better readability, but you can see from the tags that are used in there that it's basically just a simple HTML table that has all the elements and the values in a table structure. So that's a very simple representation of this patient's demographics. And the idea behind this narrative is to have like kind of an emergency scenario. If two systems are exchanging information and for some reason the machine readable parts cannot be processed by a receiving system, it can still use this HTML encoded human readable part and display the information to the end user, even if the data cannot be processed. In the yellow box, you find an example of the usage of an extension, meaning that if you want to have an element in your resource that has not been considered part of the 80% rule, you may have to use an extension. In this example, we can see a US-specific extension for patient's race. That's something that is only used or primarily used in the US, but not in other countries. So this has not been considered as part of the 80%. And so now there is a US-specific extension to add this, this information to the resource. In the green box, you can now see the elements that are within the 80% rule. So these are the generic patient elements as per the FHIR specification. These are the usual things like a patient's name, their birth date, their address, their administrative gender, etc. Now let's talk for a little bit about exchange paradigms and about the questions on how to move these FHIR resources around between systems. The REST paradigm, the web-based approach to exchanging data, is probably the most popular in FHIR. And FHIR often is being considered as being just that, being just this web-based, REST-based exchange of information. But that's not actually the case. It's REST-based exchange is just an option, but there are other options as well. You could use FHIR to implement messaging the same way that V2 was moving data around. And messaging is even not tied to one particular protocol. You could use messaging via HTTP, but you could also use messaging via file transfer. And there's also the possibility to create operations, to expose specific services through the FHIR APIs that are provided on a server. And then we have this everything else box, which basically means that you can use FHIR resources and exchange them in any way you like. Because quite often you will find that in your scenario, you will have to rely on pre-existing national infrastructure, whatever that may look like. So this is basically why FHIR is leaving it open to choose whatever exchange paradigm your situation requires you to choose. Then finally, we have the part in the middle, storage. That was actually never the intention of FHIR. FHIR has always been designed to be an interoperability standard, a communication standard. But the implementers that went to the connectathons early on, they had quite a lot of imagination, and they were usually operating on a green field. They were not using FHIR as a facade to communicate data that was existing in proprietary databases. They were quite often building new implementations from scratch. And so they had a lot of freedom in choosing their infrastructure, choosing their design. And quite early on, they came up with the idea saying that if we already know that we want to exchange our data using FHIR, and we need to create our own brand new database, why not use FHIR also as a database model? And they started to use XML or JSON native databases like MongoDB, CouchDB, and so on, and created FHIR APIs on top of these XML or JSON native databases. So FHIR not only became a format for exchanging data, but also a format for storing information and retrieving information from their databases. And that has become quite a popular approach when you are implementing with FHIR. Now, if any one of you is not so much on the technical side and maybe has never heard about REST, or has heard about it but doesn't really have a good idea of what REST actually is, let me give you a very short and simple explanation, because I think everyone basically knows how REST works because we're doing it many times every day. Whenever you open a browser and type in a URL and the browser will display the page for you, that's a REST interaction basically. You've been asking the server to give you a resource, and you've identified the resource that you want to look at by providing the URL. And that's the same thing with FHIR. If you want to look at the patient's data, you basically just have to give the URL of that patient, and the FHIR server will return the patient resource to you. And it's up to you, it's your choice whether you want this to be JSON formatted or XML formatted. Quite often it happens that when we're browsing the web that we do not know the URL of the page we want to look at, so we're using search engines. And what's basically happening when you type something into Google is that your query is going to be encoded in the URL and sent to the server, and the server will respond with a list of possible resources, a list of resources that match your search criteria. And the same thing is true when you search for something on a FHIR server. You will be able to encode your query into the URL, send it to the server, and the server will respond with a list of resources that match your criteria. In this example, we are asking a server for all patients with a given name John, a family name Doe, and the gender male. But of course, we do not want this to be our user interface. So this is something that's happening deep in the background of our application systems. So you would probably need to integrate FHIR into your existing or your applications that you're currently developing. And there's quite a lot of ways to do that. You will hear talks here at DevDays about the HAPI library for Java developers, the .NET libraries, and there are so many libraries out there that you can use to easily integrate this kind of communication into your systems and provide a user-friendly interface where people, just like Google, can basically type their queries into their UI, and in the background, there's this query that gets encoded, gets sent to the server, and the response is then displayed to the user. Now, whenever there's a new standard around, there are always great expectations that this new standard will once and for all solve all interoperability problems. And the biggest problem in interoperability most of the time is that there are always different interpretations on how to use a specific standard, so that you find out that when you try to connect two systems that they are not quite that interoperable, that you need to adjust a bit of on both sides to actually make it work. And the expectation that just because two vendors decide to implement FHIR, that you will end up with a plug-and-play interoperability is something that I like to compare with the expectation that if you give two children boxes of Lego bricks and ask them to build a house, that they will end up building two identical houses. That's never going to happen because they have different backgrounds, different ideas of what a house looks like, basically maybe based on the house that they live in. And so they will end up with vastly different results. And it's the same thing is true for FHIR, because there's so many ways that you can use FHIR, that you can assemble your resources to more complex constructs. The chances are that these solutions will not be identical, will not be interoperable. The solution to this problem, however, is there. You just need to add a construction plan that tells every implementer how exactly to use the standard to implement a specific use case. Now, going back to our children in the example with the Lego bricks, if you give them these construction plans and tell them to build a house exactly the way it is described in this plan, there is a high chance that you will end up with identical houses. And even if they are not identical, you can use the construction plan to find out which one of these children maybe made a mistake and where exactly the mistake was, and you can correct it. So the implementation guides are basically the magic sauce that makes FHIR interoperable. And that's why implementation guides are not just an afterthought, something that is added to the specification. They are actually a part of the FHIR specification. Implementation guides are also FHIR resources, so they can be searched and accessed and moved around through the FHIR API like every other resources. And as well as other resources, they are both machine readable and human readable. What you find in implementation guides are what we call profiles. Profiles describe how to use a FHIR resources in a specific context. And profiles usually are just constraints on an existing FHIR resource. Constraint could be, for example, that a minimum cardinality of patient name is set to 1, making the field mandatory for a specific use case. Or it could be a rule that needs to be applied to any resource, that if this field has a value, then this other field cannot have a value as well. This is something that could be specified in these profiles. Profiles will also tell you which extensions you need to use for your resource. And you can use these profiles to validate every instance that you create and to instantly get feedback whether your instance complies to a specific profile. And these profiles, these resource profiles, they provide syntactical and semantical interoperability. So basically these implementation guides and all the contents of these guides, they are basically adding the I to FHIR. They create interoperability. So it's very important before you start implementing FHIR to find an implementation guide that is suitable for the use case or for the problem that you are trying to solve. And the first place to look for implementation guides is the implementation guide registry. That's the easiest way, the easiest place to find implementation guides. But then there's also the FHIR community where you can just go and ask people whether there's anything out there that you could use. And even if you don't find an existing implementation guide for what you are trying to achieve with FHIR, then your first step should be to find like-minded people in the FHIR community and start creating an implementation guide. Try to find common solutions to the problems that you're trying to solve and document the solutions that you came up with in an implementation guide and make it available to others. Because everyone that will find your implementation guide and decide to implement this then will be interoperable with your solution. Now, the most important rule when you are using FHIR is please never do it alone. The first step should be to reach out and find the community, and that's quite an easy thing to do. There's the international FHIR Chat. That's easy to find on chat.phir.org. You can sign up for free. You can even use your Google account or your GitHub account to sign in. And that will land you right in the middle of the international FHIR community. There's a lot of activity going on there, and there are people asking questions and people discussing and people helping each other out. And the first thing that you should do when you open this chat for the first time is to take a look at the streams menu. Streams are basically topics that are being discussed. And there are already hundreds of different streams. For example, if you're using a specific implementation guide or a specific framework to implement FHIR, chances are that you will find a stream that is dedicated to this IG or to this technology or to this tool that you are using, and you will find the people discussing this particular aspect in that stream. If you are not from the US or not a native English speaker, you may also want to look for streams that are particular to your country. And you will find that many countries all over the world have already created one or more stream that is specific to their local requirements and where they discuss in whatever language is being used in that particular country. So I really want to encourage everyone to sign up to the FHIR Chat and don't be afraid to ask questions. Even if you feel that it's a newbie question or maybe a stupid question, there are no evil people on the FHIR chat. You will get very kind responses from people. You will get fast responses, and it will save you a lot of time. If you're trying to, to find sources on the internet, it can be quite difficult because there's so much information out there about FHIR. And you always have to remember that FHIR has been out there for quite a number of years by now. And the whole development of FHIR has happened online, has happened in the open. So the information you find out there did not start when R4 was released. There's information there that maybe goes back to very early drafts of the specification. So it can be quite easy to walk into the trap that you're Googling for some information about FHIR on the web, and you find something and you read the whole page, and only later you may find out that your source has been from 2016 and only applies to DSTU2. So it's a little bit difficult to decide the quality and the relevance of that information. So it's always important to check the dates and check what FHIR release that your information applies to. And that's also the reason why usually it's helpful, if you're looking for something in particular, to just ask the community, because there are people who can tell you the best places to find information about any specific topic. They will tell you the right people to talk to, the right people to step in contact with, and they would also know maybe about things that haven't been published as widely yet, about who's currently working on a specific implementation guide and so on. So that's really the most important advice that I can give to anyone. Join the chat and don't be afraid to ask questions. Now, you can imagine there are quite a lot of wordplays going on with the term FHIR, and even with the logo and everything happening. And there are quite funny names for products out there that play on the fact that the FHIR standard is pronounced exactly like the word FHIR. But in Germany, the pronunciation of FHIR means party. The word FHIR in German stands for party. So you can imagine that we have our very own brand of FHIR wordplay. And so I would like to sign off with wishing everyone frohes Feiern, as we say, which basically means have a nice party. So that's it for the FHIR introduction. Thank you for listening. And again, apologies for the problems that we have on the live feed. I hope you can enjoy this, this recorded version, and see you around at DevDays. Enjoy yourself. Bye.